Hello everybody, it's me again. Today's video may seem a little bit different. That's because we're in a totally different editor. We are actually inside of Visual Studio Code, which is my favorite editor, one that I use pretty much all the time for various kinds of development, either for writing smaller code or just doing web development, which is what I do most of the time. So if you're wondering where you can get it from, it's actually really simple. Gosh darn it, all you have to do is go to the link in the description or just type into your browser code.visualstudio.com and you can download it for Windows and for Linux and for macOS. It's multi-platform, it's a really good editor, it's extensible, you can get various kinds of extensions, as you can see. I already do have a few extensions installed, but that doesn't matter. The thing that matters is it's an editor that you can get for free and you can install really easily, and it doesn't take that long to install. Also, it's been a little bit of time since the last time I showed you my website. It's been completely reworked. I have my own custom icons now, my own custom theme and everything. Also a custom CSS file and everything that I've made up from scratch. And yeah, so I'm no longer using somebody else's themes or anything. Everything here is made from scratch by me. As you can see, everything works the way it should. The animations, there are still some I managed to retain with my own like code, but the animation where it like scrolls up and down has been lost somewhere. I'm not able to get it working. I'm still working on it though, so I hope I'll be able to get that working. Anyway, I've been rambling on for far too long. Again, just go to code.visualstudio.com and download the editor that I'm using today. It's a really solid editor and I would recommend everyone to use it. So back onto today's topic then. So today's topic are loops and arrays in Java. So what is a loop? A loop is essentially let's say it's a section of code that will constantly repeat a block of code that you put into it. It's useful if you want to repeat a certain task multiple amounts of times. So the thing that I'll be going for here is I'll be showing you a really simple loop, a really simple one. Let's say we define ourselves a variable. So let's say we have a full number variable and that will be the number I, for example. Most developers use I as a way, but first I'm going to show you a while loop, what it does, and then we're going to cover all the other loops that are there, and then various kinds of things you can do in case something happens in a certain loop. So let's say we give it the value of 0, and then this will be a while loop, so bear that in mind. So how do you define a while loop? It's actually really simple. All you have to do is you have to type in while, if you can type that as. So while, as you can see, it already does the syntax highlighting, which is one of the features I like about Visual Studio Code. Like pretty much every other editor does it, but it just looks a lot prettier on here. Also, you have the option to open up your terminal here, which in Windows happens to be PowerShell. It, however, works the exact same way. All you have to do is go to View and no, it's actually here Terminal, and you click New Terminal if it hasn't opened been yet. So you just click New Terminal, and this thing should pop up, which is the terminal that we're going to use to compile our code. And so we do not have to open any other tools. We have everything inside of here, so it's pretty much a full-fledged IDE. Let's say that we want to repeat it about, I don't know, 5 times, I guess. So we do this. Pretty much we're telling is like, hey, repeat everything that's in here so far as it's lower than 5. So if I type in system.out.println and I give it the number I, so we can see what's actually doing. If I decide to compile this right now, which it will compile just fine, and run it, watch what happens. It keeps on printing out zeros. And it will keep on doing that indefinitely because we are not incrementing it. So what incrementing does, it increases the value of the variable that's in here, which in our case is the I right here, we are not increasing a variable, so it's gonna keep on constantly printing out zeros because it's still true. This while loop holds true if the condition is true, and the condition will be always true because we have defined it as a 0 at the beginning. So to make sure it prints out just from 1 to 5 or 1 to 4, it will be like print out 5 times. You'll get what I mean as I show you what I'm doing right now. So all you have to do is type in I++ to increment it by 1 each and every time. So the way a while loop works, it executes every single line of code line by line, so it works like a normal code block, but it will repeat itself until the condition is no longer met. So in our case, it will go in here, start as a 0, print out a 0, increase its size. It's now 1. Is a 1 lower than 5? It is. Write it out. Increase. Is it 2 lower than 5? Okay. Write it out. Increase. Is a 3 lower than 5? Yes. Write out. Increase. Is a 4 lower than 5? Yes, it is. Write out. Increase. And now, here's the important thing. By putting it like this, you would say, well, what does it do at a 5? At a 5, it's not gonna do anything. It's just gonna leave. It's going to leave the loop. It's going to exit. Let me show you. Let me compile this and run it. As you can see, it prints out from 0 to 4, just like I mentioned. But it's not going to print out the 5. If you want to print out the 5, you have to put a equal sign right behind the lower angle bracket, the left angle bracket, the sharp bracket. So if you decide to compile this and run it now, the main difference will be that it will print out from 0 to 5 because it will be equal to 5 now. And that's a while loop. That's all you have to know. There's also another while loop that's similar to this. It's called the do while loop, and pretty much the only difference is, let me copy this section of code and change it to do. Actually, let me just copy this entire section. Or let me just copy this entire thing and just comment it out. Oops. There are also like various different keyboard shortcuts. I still haven't like learned them all yet, so I'm just gonna comment them out real quick. Okay, there we go. So we have just our normal code block, and all I'm gonna do is I'm gonna take this, copy it, and replace it with do. And I'll put the while tag here with this semicolon right here. So pretty much what I've done is I've written the exact same thing as up here, but I've done it using a do while loop. So the only difference between them, they work pretty much the exact same way. The only difference is the condition is at the end. So if you get a task where you have to use a loop with a condition at the beginning, you can use a while loop or a for loop, as we're going to cover in a second. But if they say, well, you need a loop with a condition at the end, well, to do that, you use a do while loop. And what it does it and then checks the condition. And it keeps on doing that. And once it's done checking the condition, it will leave the loop itself. So it will pretty much leave the entire loop. So it works pretty much the exact same way like this one does, but it's defined in a different way and it uses a different structure, obviously. So if we decide to compile this now and run it, it will work pretty much the exact same way. See? It works the exact same way. The only difference is that we are using a different syntax, but it does the exact same thing. It's still considered a while loop, which is important, obviously. So with that done, that's another loop defined. So what else is there for us to do? Well, since we've covered the while loop, the other logical loop to use is a for loop. There's also a for each loop and such. I'm going to cover it as we are going to go through each and every one of these examples. I'm just looking for the examples that I've prepared for you guys. So let's first do a for loop. So pretty much what a for loop is, let me comment this out because we're not gonna need it anymore. So pretty much what a for loop is, it's pretty much another form of a loop that you can use to to not repeat yourself, which is really important if you're writing code. So the last thing you would like to do in your code is just to keep repeating yourself, which is not ideal. So a thing you can do is use a for loop for something like this. So we will pretty much use the exact same example as we used here, but it will look much cleaner and it will do the exact same thing. Let me show you what I mean. So to define a for loop, it's really easy. You type in for, put the normal brackets, put the squiggly brackets. I recommend that you put the squiggly brackets like this. Some IDEs may put it right below the for loop, but it just doesn't look good in my opinion. And all you do here is you have to define three things. You have to define three statements. The first statement is executed before the code inside of here is executed. Pretty much it does something first before anything else that's in here. So for example, we can type in int I will equal 0. What this will do, and this is also the reason why I commented this out, is we've done pretty much what we've done here on this one line right here, but it's inside of this for loop. So that's already one line eliminated from our code. Bear in mind, good code is also determined by the way you structured it. So it's also good to remember that you cannot repeat yourself all the time. It's always better to use different kinds of loops, statements, conditions and such to make your code work the exact same way as it did before, but you want to make sure that it's clean and easy to read and easy to understand. I have been coding for a few years now and I'm far from being an expert in this, but I have a high enough of a skill level on my own that I'm able to explain hopefully everything in a manner that does make sense. Also, if you want to support me, make sure to check out my Patreon and other social media platforms. I'm trying to make this into something of a part-time thing when I teach people how to write certain bits of code and such. Anyway, that's beside the point. Also, let me know which programming languages you want me to teach, because I was personally interested in learning a bit about Ruby, for example. It seems interesting, or maybe even Rust, but you just have to let me know what you want to see. I'm just gonna do what I want to do. Anyway, I still haven't covered JavaScript yet, so I might cover that because it's an important part of web development. Anyway, I'm rambling on for far too long. So next up in the for loop is the second statement. The statement number 2 defines a condition. So this is pretty much what you would type in here in the while loop, in the do while loop in the brackets right here. But what we're doing is we're going to type it right here because the second statement is the condition that it's going to check. So it does this, but it will also check the condition if it's still met. So to do this, we just type in I is lower or equal to 5. And what you will notice is that I'm separating each and every one of these with a semicolon. That's because each one of these in this for loop statement is a different statement itself. So they cannot be put in one line and then ended with one semicolon. That's not how it works. However, the only part you're not gonna end off with a semicolon is what will be done after the code block has been executed. This is essentially this part right here in our do while loop, or in our while loop right here. So what we do is we do this thing, this statement, and then we increment. We do the exact same thing here, but it's written in a much cleaner way. So what we want this for loop to do is we want it to set at the beginning of the for loop to set its value to 0, check if it's lower or equal to 5, execute whatever it's in here. So for example, I'm gonna copy this section of code. I know I shouldn't be copying, but and it will write it out for us. That's what this line does. This one line pretty much prints it out. Then it will increment, and then it will check the condition. If the condition is met, for example, we start at 0, we check if 0 is lower than 5, it is, we execute this, and then we increment. Then we check again, is 1 lower or equal to 5? It is lower. We write it out, we increment. And then again, is number 2 lower or equal to 5? It is. Write it out. Increment. You get the idea. So if I decide to compile this, again I'm using the same commands as I've been using throughout this entire time, and then I run it, it does the exact same thing, but with the added bonus of possibly reducing our code by 2 lines and making it look cleaner and more professional. If you want to repeat a certain action, I would recommend that you use a for loop for it. However, if you cannot use for loops, use either while loops or use also just either use while loops or just for loops. It's a really good one. There's also a for each loop, but I'm not gonna cover it. It's not really necessary. However, I think for the sake of completion, it's important to cover. So what a for each loop does, it loops through an array. I haven't explained what an array is, but I'm gonna cover it in this video at the later part. So I will most likely return to this. So I will highlight it for myself to return to this at the end of the video so that we can have a full circle so we understand everything. So we will cover the for each loop once we've covered arrays, which we will cover. That's also why this video is a bit longer again, because I'm trying to explain everything so that everything makes sense. So that's a for loop for you, but there's also a fairly interesting thing. So we can combine for loops and if statements. Those who have watched my channel for a while, I have covered if statements in if statements, else statements, and else if statements or if else statements in the last week's video. So we will use that knowledge in this next section, which will be learning about breaks and continues. So what it pretty much does is, let's say we want, let me just copy this section of code because it's gonna be reused a bunch, and I'm going to cover it in commands, because in my last video I had a bit of problems compiling every bit of the code for you guys because I had to go and separate it into a different file. It's actually easier for me to just comment it out and then copy and paste it again, because it's easier for me, and I can just then take the file, upload it, and you guys can just, check the code out yourself and see what it does. And also I have quite a few files here from all the lessons that I've taught, so it's fun for me to do these things. So we can use a for loop to our advantage here, so I can tell you what a break is, what the break statement does. You might have been looking at some different bits of code and going, what is this break statement in that loop? Like, what is it for? What does it do? What the break statement does, let me just write this out so you guys understand. So let's say we're going to count from, I don't know, from 0 to, let's say 10. And for some reason my numlock got turned off. Let's say to number 10. We're going to count from 0 to 10. And what we want to do is, I don't know, let's say we're going to use an if statement here, okay? So it's easier for us to understand. So what we want our bit of code to do is we want it to leave the loop as soon as it reaches the number 6, for example. To do this, if you look at the variable we're using the I variable, so you have to reuse it again. So for example, I said I want to break it as soon as it reaches the number 6 variable. So what I want it to do is I want to break the counting as soon as it reaches the number 6. To do this, I type in I double equals, because we are checking if it's equal to a certain value, which in our case will be 6, because we want it to break out of the loop once it hits the number 6. To do this, you type in break. That's it. So what we have done here is we're going to go through the for loop once again, and we're going to check. There's another check inside of here. what it does, it checks if the I variable is equal to 6. So it will keep counting out up till number 5 and print out number 5. It gets to number 6. What does it do? It checks. Number 6 is in fact lower or equal to 10. It is in fact lower. It will check if it's equal to 6. It will say, oh no, I'm equal to 6. It's going to leave the entire loop, so it's not gonna bother continuing. So what we should see is it's going to print out from 0 to 6. Let's see that in action. So let me just compile this. Again, it should work, obviously. And we run it. Did you see what happened? It went to 6, but didn't even bother printing it out. If you wanted to print it out, you would have to move this line of code above it. Let me show you. I'm gonna move this line of code above it. The difference between the one that we've run just now and this one is you should see the number 6 appear and then do nothing. Watch what happens. I'm going to compile this again and I'm going to run it. Watch what happens. It prints out all the way up to number 6. That's because we moved the instruction before it even got a chance to break itself. So it still wrote it out, but it was like, oh, I'm number 6, I'm gonna leave. So pretty much what this code did before it is it did the exact same thing, but it did not get a chance to execute this instruction right here. So what we've done is we've broken out of it just like we wanted to, but it didn't even bother executing this line of code. So it's also important to remember the way you position your lines of code, because you cannot just put them willy-nilly inside of a loop and hope it will work. You need to remember the order at which you have your instructions in, so you don't break something on accident, which is the last thing you would want to do. There's, however, another thing you can try and do. So let's say you don't want it to exit at number 6. Let me just let's say we will use the exact same code we used just now to print it all the way up to number 6, okay? So let's say, let me just copy this and let me comment it out. Also, for those wondering, I'm not even gonna like bother including the previous one. It's exactly the same. Cannot type today because it doesn't really like matter. It will still work no matter what you do. Anyhow, so next up, I'm going to just paste this in to make my life a bit easier. Yeah, okay, good. I was just checking everything's okay. So here's the thing. There's also a continue statement. So the continue statement, pretty much the difference between those two is it does a skip. So instead of completely breaking at number 6, I'm going to write here continue. Watch what happens. So watch what happens. Remember this sequence of numbers, okay? We've got from 0 to 6. Remember that. Okay, what's gonna do is it's gonna continue all the way up to number 10, but it's going to leave out number 6. So it will go 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. Don't believe me? Watch. Let me compile this. And it says we have an error at line 33. That's okay because I put a... Is it fine? No, it's not. That's because there was one bracket extra. Okay, there we go. This should have done it. I put in bracket there on accident, so it should work. Yep, I just copied it in the wrong fashion. So this code wouldn't even work for you guys if you uncommented it. Let me fix that for you. There we go. So anyway, so what's gonna happen now? Essentially, what's gonna happen now is if I execute this, actually let me save it again. And let me compile this. It should compile just fine. As you can see, it does. So if we run this, watch what happens. So remember how we... okay. Oh, I didn't come... Oh, I'm a dunce. Okay, so this is what I mentioned before. What you want to do is you want to take this line and put it at the back. So it did skip it, but you did not see the change in here, because remember what I said about the instruction order, that it matters. Well, this is the exact situation right here. It still wrote it out, and it did skip it, but it wrote it out before skipping it. That's why you see all the way from 0 to 10. Now what it would do is skip number 6. So if I execute this now, what happens? We've got 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. So again, the order of instructions is important. It really does matter. Here it didn't matter because we're breaking out of the loop. Here it does matter because you want to continue once you're out of that. And that's what you want to do. You can also do the exact same thing for while loops, but I only wanted to cover it for for loops because it works in pretty much the exact same way as it would normally. There is nothing different. Yeah, it works the exact same way. Again, you'll just put a condition and check and do what you want to do. Let's say you wanted to skip number 6. You go over to the code, for example, I don't know, let's say you want to skip number 4 in this code right here. What you would do is, if you want to skip number 4, all you would have to do, let me show you the example, because I feel like I'm being a hypocrite right now by not showing you what I mean. Okay, so let me just quickly, I'm actually gonna comment this out because it's gonna scream at me and do weird stuff with my code. Okay, and I'm going to comment these ones out just for completion's sake. I'm going to show you what I mean. So I'm going to use just one of these as an example. So watch what happens. Let's say we're checking again from numbers, let's say 10 again. Why not? So it's consistent. So what we want to do is we want to, what do we want to do? We actually want to put the break thing right here, or do we? Yes, we do actually. So let's say we are going to do the exact same thing we did with the break thing in the first example. So what I'm gonna do is I'm actually gonna take this from here, this section of code, and I'm gonna paste it in and remove these brackets because they will cause us troubles later on. There we go. So pretty much what it's going to do is at number 6, it's going to exit out of the loop and not gonna bother. So it does pretty much the exact same thing as it did here. So this section of code does pretty much the exact same thing as this section of code does, but it looks a lot janky, and that's why I don't recommend using while loops as much, and that's why you should use for loops instead. To prove to you that it does in fact work the exact same way, I'm going to compile this code and run it. It breaks at number 6 before even writing it out. If you want it to be written out, guess what? You would have to change the order once again. Let me show you. I'm gonna copy this code, and that's why also why these code files are actually so long, because I'm explaining pretty much every single thing, and I'm also not repeating myself because it's like, you know. That's why I'm going to copy this, and I'll move this condition at the beginning to prove to you again that instruction order does actually matter. It does make a difference. So what will happen is it will not even print out the number 6. It will just leave the loop at number... Will it though? It's like actually not gonna do anything, I think. Well, let's see if it does actually matter here, because I've never like actually had to use a break command in here. So as you can see, it doesn't make a change here, but pretty much what like is important is, let's say I moved this over here, it would be pretty much the exact same thing as here, but it's just, you know, it just doesn't matter in a do loop, in a do while loop essentially, because the only thing that's different is it doesn't, like, you know, execute them in a like separate order, it just goes and it does the exact same thing as it did here. So it still got to the end, but a difference is if I had a debugger, it wouldn't even bother incrementing. It wouldn't even like increase. It will still say number 5. At least I think. No, it will say number 6, but it will leave, because then it wouldn't make sense. So it will like print out number 5, then increase to number 6. So if you wanted to, you know, work with this a little bit differently, it will still increase to number 6 even in this statement, but it will leave as soon as it's number 6. So it does work, in fact, and it does make sense because we have 6 numbers here. So, you know, again, I'm rambling around it, but I'm trying to explain everything in as much of a sense as I possibly can. So with this covered, with loops fully covered and stuff, we can cover arrays. Now arrays are actually like really simple. If you have watched some of my previous videos where I covered arrays, yeah, let me just, you know, comment this out again because we're not gonna use it. I also like how Visual Studio even like how VS Code even like tells you like, hey, you forgot to save your code. It's actually really nice of Microsoft to have implemented this feature for us. So, so what are arrays? Arrays can be thought as blocks of like data. You can have one variable that can store multiple values, multiple instances of values in itself. It can either be an array of texts or strings in the case of programming, or it can be an array of numbers. So let's say we wanted to, I don't know, make a list of items that we wanted to buy from the store. To do this, you would type in string, and if you want to create an array, you have to put in these square brackets. That's how you define an array, and then give it a name. For example, I don't know, how should I call it? I guess let's call it a list, or what do I want to call this? Let's call it a shopping list. Why not? I just wanted to see, so shopping list. I just want to see if there's a better name for this, but I guess there's not. So shopping list, and our shopping list will have various items in it, and to write out the items you have to put them in these squiggly brackets. And what you want to do is, since this is a string, if you remember from the video where we covered data types, strings are defined using these double quotes. And this is a unidentified like list. So what we can do is we can put as many things as we want in here. So for example, let's say we want, I don't know, 3 items, let's say. Or let's do 4. Let's do 4 items. Why not? Let's do 4. And let's say apple, for example, banana, orange, and let's say kiwi, like not the bird, like the fruit, kiwi. So that's our that's one way you could define an array. And so pretty much what we've done here is we've defined a string array called shopping list, and it has elements such as an apple, banana, orange, and kiwi. These are the like items in it. So so let's say we have this defined, but what if you wanted to define a number array? So let's say you want to define a number array. That's actually really simple. Again, it's very similar in structure. So what you do is you type in the data type. So again, int, and let's say we want an array. If we want an array, again, put in the square brackets. This is what's used most of the time. If you want to use an array, then we give it a name. For example, I'm really lazy, so I'm just gonna call it num_r like this, because why not? And then we give it its elements. Since this is a number array with full like numbers, we can type in, I don't know, 10, 20, 30, and 40, for example. So we do 10, 20, 30, and 40. Not 14, but 40. Cannot type. So what we've done here is we've defined ourselves two arrays that we're going to use. We have an array called shopping list. Actually, you know what? Let me do one more thing. Let me change this num array to like amount, and change this to 1, 2, 3, and 4. And let's do bananas, oranges, and kiwis, and leave that apple because we're gonna buy one apple, for example. That actually kind of rhymed. So what do we want to do here now? Well, I saved it obviously. So let's say we want to access this and put down, like, let's say let's say we want to print out like 1 apple, 2 bananas, 3 oranges, and 4 kiwis. So to do that, it's actually really simple. All you have to do is, I'm going to show a better way using loops. This is also why I wanted to cover this. So this also pretty much ties in with the for loop where we can use it to access various things. But I'm going to cover the for each loop a bit later. Just be patient. So let's say we want to print out, I don't know, 1 apple, 2 bananas, 3 oranges, and 4 kiwis. So again, what you do is type in system dot out dot print line, and here you type in what you want to print out. To print it out and to chain those strings together, let's say we want the amount first. So we do amount, put in the square brackets, and we want the first element of the array. Arrays count in a manner from 0 to n, which means they count like this: 0, 1, 2, and 3. I hope this makes sense. It will make sense, as you soon will see. So we want to print out the amount, which will be, you know, you can click to check if it's written out correctly. It is. So we want to print out the first element of our array, which will be a 1. And when we want to add to it is the first element in our shopping list, which will be apple. Watch what happens. Shopping list and 0. So if I decide to compile this code now, it will compile, and now I run it. As you can see, it prints out 1 apple, but it looks a bit weird. It doesn't have a space in it. We can solve this really easily. Put in another plus in here, put in double quotes, and put a space in it. That's how I add spaces to print line commands, or to, like, you know, write lines and such. It's easier, it makes it a bit more readable this way, I think. So this is how I've decided to separate these two. So if I compile this and run it again, you'll see it says now 1 apple. But let's say you want to print out 2 bananas, 3 oranges, and 4 kiwis right after that. Well, one approach that you might have thought about while I was writing this out is, let me just paste this a number of times, and let's say we want to do it like this. That's how you would do it if you wanted to print it out for each and every one of these. Again, remember, we're counting from 0 to 3 here, because 0, 1, 2, 3. Hopefully this does make sense. So if I run this, it will work, but it's just sloppy code. It doesn't look pretty. Like, it will get the job done. 1 apple, 2 bananas, 3 oranges, 4 kiwis. It doesn't look pretty. It's not good. That's why I covered loops first. That's where our loop comes in. So what you can do is, I'm gonna remove all of this because it's not necessary, and I'm going to write out a for loop here, because I like using for loops. It's also one of the more used ones. And what I'm gonna do is I'm gonna take this section of code, this one line. Watch what happens. I'll replace all those 4 lines of code with just, you know, without repeating myself. I can just replace it in theory with 1 line of code. In theory, even though it's like 3, but you know. And let's say when I change this to I, you'll soon see why. If you remember how I mentioned how for loops are defined, it's actually like this. I'm actually gonna yoink this. I don't want to rewrite it again. And I'm gonna change this to, since we have only 4 elements in it, so 0 to 3. So it should do the exact same thing as that ugly piece of code, the ugly block of us repeating this one line. A goal in writing a good-looking program or good-looking code is to minimize as much as you can. So if you are a minimalist, it's perfect for you to use various kinds of loops and some instructions that can repeat certain commands, because you don't have to rewrite it again, it will just do it for you. So, watch what happens. If I decide to compile this and run it, it does the exact same thing with fewer lines of code. I know I wanted to mention there's also a way of changing elements in it. For example, let's say we want to, well, this is execute. Let's say before we execute it, we want to change, I don't know. Let's say we want to change our apple out for a pineapple, for example. So what you would do is you will type in shopping list, FG, and then 0 because you want to change the first element, and then type in what you want to change it to in these brackets. So pretty much the thing you would do is, let's say you want to change apple to pineapple, for example, and yeah. So if I run this now, the change what you should see is instead of apple up here at number 1, it should say pineapple. And see, it does, it says pineapple. That's how you would change an element in an array. Bear in mind, we still have apple here, but before we wrote it out, we changed it to pineapple. There's also array length, looping through an array and such. That's actually what we've done here. We're looping through an array. We can also loop through an array with for each, which I'm going to show you right now. Actually, it's really simple to do. We're going to use another for loop for this, but I'm going to most likely comment it out. Again, if you want to use this, just... And I'm also going to comment out this pineapple thing because it's related to this section where I explained it. So we're going to keep our arrays like this. We're going to use another for loop this time, but this time it's going to be a for each loop. It will make sense, trust me. Instead of worrying about the amount of items in an array, let's say we did not know how many items are in our shopping list or how many items are in our amount. What we can do to eliminate all these thoughts is we can, in fact, you know, print them all out without having to worry, like skipping over something. It's really simple, actually. What you do is you type in for, put brackets, put those squiggly brackets, and what you would do is you type in string, since we're going to cover a string I. Put these double dots, I would say, and then the name of the array you want to access. The array we want to access, since it's a string, bear in mind you have to keep the data types the same. It will be our shopping list, so type in shopping list and then print out what it has to say. Again, to make this simple, I'm going to type it out actually. Out.println, and we're going to print out each and every element in the array from the for loop. So pretty much what we've done is we've done the thing where we are going to print out each and every element from this array. Instead of having to worry about like how long it is, how many numbers to use, this is a surefire method because you know it's an array and all you have to think about is the data type that it uses. And that's pretty much it. So let's see what happens if I decide to print it out. So I compile this and run it. And what happens, we print out each and every item in our array. To check, I'm going to leave this down here. Look with me. Apple, apple. Bananas, bananas. Oranges, oranges. Kiwis, kiwis. It does work. But let's say we want to add pineapple to the list at the very end. Well, or some other item. You can, it will work. I'm just gonna add it real quick and remove it. So let's say pineapple, like someone wanted to add a variable to it. What you would do in this case right here is you would have to change the number. And if you're using it in different places, you would have to change it as well. The reason why I would recommend to use this one instead of this is it makes it easier. You don't have to worry about anything. Look, I didn't even touch this section of code. I'm just gonna compile it and run it. And what you will see as a difference is there will be pineapple at the end. So it can dynamically increase its size depending on how many items are there in an array. However, I wanted to just keep it simple, so I'm going to get rid of the pineapple thing to make it all simplistic. And again, I'm just gonna compile it. You know, I didn't have to change anything. Can run it again and it works. That's because it changes its size depending on how many items are in it. And once it reaches the last item, it's gonna exit the loop. And that's pretty much it. That's everything that you need to know. It's been a little while until I explained everything, but again, it's important to understand everything. This video is again a bit longer, but I went through multiple things at once here just to make sure that everybody understands what I'm talking about. Again, I also started streaming on Twitch a lot more lately, so make sure to check me out there. I didn't add it to the contacts on my website as of now, but I do plan on doing that at some point, not now. But yeah, that's pretty much it. I hope this video helped you understand at least a little bit about this. If someone wants to add timestamps to this video, you can. I don't really care as much. I just returned it to the original size. That's why you cannot see the code as clearly now. But I can see it. It's enough for me. So yeah, that's pretty much it. I hope you guys found this video enjoyable. Again, if you found it helpful or know someone who might benefit from this, share it around with someone or anyone you know who's getting into programming or is trying to learn anything new. And on that note, I'd like to wish all you guys that you stay safe, have fun, keep on coding and feed your curiosity this way, and try to learn new things every single day. And I'll see you guys in the next one. Bye.